coming in. What I wanted to do tonight was talk about control systems for control line aerobatics, because I see a lot of misinformation, a lot of mythology, a lot of what I refer to as excess technology that just gets in the way instead of being a help to anything. And so what I want to go over is hardware that I use, and also some other concepts, because regardless of what hardware anybody uses, the control ratios, how sensitive the system is the biggest thing that gets in the way of people flying precision aerobatics. Most people set up their control systems far, far too fast. What I mean fast is you move the lead outs a little bit, and the elevator's going like this. And on my ringmaster here, that's full down, and that's full up, and you see how much the lead outs will be. And I fly it on a 4-inch handle. Now, that works for me. Where my awareness of a control system setups come from was back when I first started flying Stunt. I was about 12 years old. And the first home-built or scratch-built airplane I ever built was a PT-19 by Dave Hemstroth. And actually, there's a PT-19 out there in the garage. It's one of Dave Hemstroth's airplanes that Will Davis inherited and transferred to be electric.
Where's my phone?
And it's actually Dave's airplane, but in Dave's original article in American Model, the PT-19, he made a point about the second paragraph of, please note the control system as designed or designated on the plans. He says, if you fly anything else, use your control system that you're accustomed to. Because, you know, if you keep changing, every airplane is going to be different. The Vico kits back in the 50s had a system that had 2/3 flap, 2 parts flap, 3-part elevator, and very sensitive. Just jiggle it and it'd slap up and down. Well, it's time to find out, dealing with Joe Wagner, those guys used to fly on handles with a spacing like this. You know, we fly on a 4-inch spacing. Bob Gieske's one that's on a 5-inch spacing. So all of those things matter in terms of how sensitive the airplane is. Any control movement beyond 30 degrees is wasted, because all you're doing is creating drag and slowing the airplane down. So again, this, you can see how much this moves in max, and in most even in squares it moves about like that. And when I'm flying, I was third today in expert profile. I've got it set up so with a 4-inch handle, I move about like that, and the elevator does about that much. So what that allows is it allows you to come out of a maneuver and go and just lay there. You just hit it and lay there. Most people touch it and you get these things. And that's because the controls are too sensitive. And then what people do to compensate is put nose weight in the airplane. Now you got 2 problems. You can't start it turning because it's nose heavy, and you can't control it because it's sensitive, which is 2 problems. You can't desensitize an airplane with nose weight. You have to have the control ratios that you like, whatever fits for you. And that's one of the things I try to encourage people to do is experiment. Try small handle, big handle, long handle, overhang, short, whatever it is, and try different things so you learn what affects what. I saw a fellow out here today flying, I don't know, it may have been a Tiyosaki or some profile, and he had a handle that had what's called overhang out about this far. And you have to do this to get the airplane to turn. Well, when you do have the long overhang like that, you're moving both lines at the same time. If you have a small handle or a short handle, and this is a classic Easy Just Hot Rock, it's probably 60 years old. And it's got a short overhang from the position your hand is to where the lines pivot. This is what I grew up learning to fly on. This always my standard to go back to for a new airplane. And this is the set of lines for that airplane, 60-year-old handle. This is modern technology. Now, this works for me. This is a perfect system. I've been flying it this way for years and years. Somebody else may like something different. The Casminato handles, you can adjust the overhang. You can adjust the line spacing. But I always start with the standard Easy Just. And then if I need to fine tune something I could go to a CAS handle, set it up like this to start with, and then start making small adjustments. I don't have a CAS Monado handle with me, unfortunately, but they're readily available. You see CAS's website online in Japan. Probably the ultimate handle in terms of adjustability, lightweight, designed by a guy who's a world-class stunt flyer, knows what he's doing. Now, when I talk about the ratios, control ratios that I use, Bill went out and got a 4-inch Brodak bell crank. This is exactly what I use. There are got a zillion of them in the hobby shop. I drive the push rod from the innermost hole. It's got 3 holes in it. I drive the push rod from the innermost hole, which is looking at this 1/2 inch, 5/8 of an inch off center, something like that. And then I use the Brodak control horns. They're 1 inch from the pivot to the top horn, the top hole in the horn. And then I go from the inside hole on the bell crank to the top hole on the flap horn. And that works for me. If it's a non-flap airplane, this will be going to the elevator without the flaps connected. But then from flap to elevator, you go to middle hole to the middle hole on the elevator horn. Now this is a 2.5 inch horn, or 2 3/4. I don't have my glasses on, which is all you need at the tail. The shorter the wire across, the stiffer it's going to be. And actually, you don't need 1/8 inch horns on anything. It's overkill. You know, the air will push the airplane out of the way before the horns flex, so you don't need 1/8 inch horns on anything. Well, I mean, unless you're an 80-ounce airplane flying 100 miles an hour or something, which is not practical. But the inside bell crank hole, top hole on the Brodak bell crank, or the equivalent, or Brodak controller, excuse me, or the equivalent of somebody else's hardware, this stuff works perfectly well. But I modify it. Very simple modifications. I drill the holes 1/8 inch, solder in a piece of hard brass tubing, 3/32 ID, 1/8 inch OD brass tubing. Cut it off so it's about 1/4 inch long. So it becomes a bushing, but steel push rod running in brass is incredibly smooth, especially once you lubricate it. The bell crank, I don't put any bushings in at all. I just run the 3/32 wire push rod into the hole on the horn, the wheel collar on the other side. Nothing fancy. I do not use ball rings. We've got a narrow opening in the back of the fuselage. I'll use a soldered washer. Now, if you notice here, this is a profile airplane, all the controls are internal. Makes it a lot cleaner, a lot easier to work on. And the push rod exits center of the fuselage. It's one of these horns, and it's just got a soldered washer in it, of course, to hold it. It's the old technology. Normally on a full fuselage airplane, I use plain old 3/32 wheel collars to anchor them into the horns. All the bends on the push rods go to the outboard side. Why?
Centrifugal force holds the push rod out.
Duh, and there's no load on the keepers.
Right.
Therefore, nothing can come loose.
Let me interject, Tom. There is a question here, or not a question, but a statement from Eric Cron. He says, "Hello, Tom Dixon. How are you? I'm happy with the Brodak 40s." That's to let you guys know that we will be answering any questions that you have.
Oh, cool. I didn't know we were live out there immediately.
Oh, yeah. We're live.
God, I can't, don't get me talking about politics, for goodness sake. The FBI will be at my door before you know it. Anyway, I use the brass bushings in the horns. It's silky smooth once you get everything set up. Now, again, Leroy's seen these, Bill's seen this. Wiggle the controls with that airplane. You know, it doesn't even have a straight headline. The horn acts as a universal joint, and no drag, no twist, no bind, no nothing. You know, you can absorb a little bit of flex. Also, with an airplane has dihedral, same thing. You don't need 2 horns.
Or lucky boxes.
Oh, you don't need them.
Too much Mickey Mouse crap.
Yeah, and people build all this stuff in, and they're really failure points. I did an article for Control Line World a number of years ago called Occam's Razor Control Systems, and this is what I'm talking about here. You want to describe Occam's Razor?
these guys build these off-camber. Occam's razor is the simplest explanation. It's probably the correct one. But these guys build these crazy Rube Goldberg mousetrap control systems, and the one that I always go back to is 1950. A bell crank and 2 horns and push rods.
Yeah.
And ball links may seem great, but there's some problems with ball links.
I do not use ball links for many reasons. One is every time they're all screwed together, you know, and every time you put something together, when you've got an engine vibrating, now with electric may not be as big a deal, but with engine vibrating, all those things can come loose, you know, at the worst possible time. The other thing is even ball links are supposed to be smooth, no play, all this sort of stuff. But if you gang them up in the system, bell crank, flat horn, elevator horn, now you've got slop everywhere.
There's four links in the system. Now, let me explain something else. Surface area. A ball link is a 1/4 inch in diameter. Do you think that's more surface area than 3/32 wire? So what's going to have less, what's going to be smoother?
Yeah.
Less area.
And plus the plastic in the ball links can expand when it's hot and
Correct.
contract when it's cold, and they can also break when it's really cold. Seen that happen. Seen them break when, you know, at the ball. I've seen them break at the push rod.
Lock
at the
up.
wire. Yeah.
Lock up
Every
and
one of them's
maneuver.
got slop under load too.
Absolutely. And so the point being that there's a lot of mythology out there about you got to have this, you got to have that, you got to have carbon fiber bell crank and titanium lead out guide or whatever. You know, this stuff works. It's worked since 1952, and it's simple and it's cheap and it's light.
Right.
And I go back to the important thing is the ratios that work for you when you're flying an airplane. Now, let me talk about a little bit about handles. These are standard. This is Easy Just Hot Rock handle from probably 1969 or so. This is a Rayco handle, which is a copy of an Easy Just Hot Rock. Like John, I can't get used to saying
No,
John.
right.
John's not here, unfortunately. But in the shop, they're readily available. It's an absolute copy. It's maybe a tiny bit thicker. But in both of these handles, the Rayco and the Easy Just, I've bushed the cable outlet because all these handles get cable flow, which you can get porpoising, you can get oscillation, because you're trying to put pressure on one line or another. Take the slop out of it, you got much more control. And interestingly enough, the bushings are the nylon lead-out stuff that comes in this Sullivan CD cable package.
Yep.
Let me talk about this for a second, these for a second. I use the Sullivan CD lead-outs and everything, all the way up to 76 powered airplanes. I like these, I've used them for years. They're brass plate cable. It's about 30 thousandths diameter nominal, something like that. I don't use any of the crap that comes with it, except the plastic tubes, but I don't use them. I use them to push handles with, or if I have fixed lead outs, I'll use them as, you know, at the wingtip for lead out guide. But the great thing about this cable, and it's $8.78. That has a lot of money for a little piece of cable. But you can do stuff with this you can't do with other cables.
Considering it started out as a 1/4.
Really. I do not bush my lead out ends. This is exactly the same way it is on the other end. It's a Sullivan cable looped around and crimped with these things that are in the shop. The thimble sets, which are overpriced at $479.
It started out as a 1/4.
But this copper tubing is, instead of using let me pass these around. Instead of using the steel or aluminum or whatever kind of crimps that come in the Sullivan cable, if you use these, it's the perfect size to make a loop it back, and then you can just squeeze it tight with a pair of vice grip pliers. I use a bench vise to make sure it's really cold flowed together, and then I run solder through it. And if the solder will flow all the way through these crimps and stick inside, and then harden the cable. I harden the cable on the outside edge or outside of the loop. The same thing on the belt crank end. Run it through the belt crank, crimp the sleeve, roll solder in it. because the solder is in itself, it's lead, it's something of a lubricating material. And if you put motor oil, got an old jug of old bottle, 20W50 Castrol motor oil I've been using for probably 20 years, just put a drop on it with a piece of wire. On the lead-out cables, they'll never wear out.
Well, we got something from the peanut gallery from Jim Lynch.
Okay, hey Jim. Well, why aren't you here?
He's sick.
What's he got there?
I'm trying to get it up. Don't want to come up. Here we go. It says, hello guys, Tom Dixon, 576 Ringmaster is awesome. Thanks, Tom. You and Robert keep preaching, Jim.
I just wonder why he's not here. I see a lot of people loop tubing through the bell crank and then they do all the gyrations to get everything okay. It's just not necessary. Bob Zambelli did a test a number of years ago with the Sullivan lead-outs, different kinds of cable. Sullivan lead-outs, I sent him a set of dummy lead-outs that he hung on a bell crank, had a motor driving it for 3 days or something like that. And the cable finally broke outside the crank. What would be going to the airplane or going out the wing. The crimp through the bell crank, nothing happened, and there was no wear on the bell crank. And it was going like this for 3 days.
I was over at Dan Winship's, and he makes the carbon bell cranks.
Yeah.
I like him because of the weight.
And he lives close by.
Yeah, he lives close by.
Yeah.
We put wires in it. We stood on the bottom, wires together, crimps like you got there, and took a screwdriver and pulled up on that thing. And I don't know, it's probably 150 pounds of test before it broke. They didn't break inside they broke after the crimp.
Yeah. I've never pulled my workbench over, pull tested like that. Put a handle on one end, have it sitting in, crimped or stuck in the vise. I can pull the workbench with it. No airplane's ever going to break that.
No.
And you spend all this time wiring, with copper wire and winding them and it's just totally unnecessary.
Now, we're talking about bell cranks. I've preached to my viewers and they've seen me install bell cranks. Why don't you tell them how you install your bell crank? Do you use suspended bell cranks?
Yeah, I use suspended bell crank.
Same way I do them. Okay.
Unfortunately, I didn't bring a sample with me. But what I do is I take the little dial-in button that comes with this and take a piece of 5/32 OD brass tubing, chamfer the end of it, taper the end of it. Take that button, stick it in the vise, and press that tubing into that button. Then, surprisingly, of course, originally the bell crank's supposed to pivot on the button, right? When you do that, it'll expand it just the right amount that it's a tight press fit to push that button into the bell crank. And I'll push it part way through, put a little thin CA in it, push it the rest of the way through, hit it with a kicker. Then cut off the ends of the brass tubing where it sticks out. A piece of 1/8" music wire goes through the piece of brass tubing. Now remember I talked about brass and steel being very smooth. Steel wire goes, 1/8" music wire goes through the brass tubing, a washer on either side, a wheel collar on either side. How simple could that be? Put it in the wing. I usually use foam wings, but I use the same technique on a built-up wing. Tack it to the inboard panel, top and bottom with 5-minute epoxy, put the other wing on, or build out the structure if you're doing it with a built-up wing. Put a plywood patch top and bottom on the outside of the wing, because the outside of the wing is the strongest part. You don't need to be pulling against a 1/16" balsa rib, pull against the whole airplane. So on an airplane like this, that piece of wire and that plywood patch top and bottom of the wing is buried in the fuselage fillet in the wing joint. No way it could be any stronger. But people often will, because it comes with a bolt, they think you're supposed to bolt it to a plywood platform, and it's going to be pulling asymmetrically. You at least need to brace it top and bottom, if nothing else.
Back in the 50s and 60s, the guys used to use a bell crank floor.
Yeah.
That, I don't know who dreamt that up, but that is so incorrect. It's unbelievable.
Yeah.
And I show this particular mounting system on all my videos,
Yeah.
and you would have to pull. It'll pull you couldn't pull it. I'll give you $100 if you can pull a bell crank out of my wing.
Yeah.
Because it's got to pull through the fuselage.
And that plywood patch that goes top and bottom, I put a piece of glass tape around the wing center to join the two halves. That plywood patch goes top and bottom and is integrated into that fiberglass tape that goes around, Then they cut off the excess wire, it's not going anywhere. There's no real stress on the belt crank this way. All the stress is pull. But once it's lubricated, you can sit there and spin the thing, and it's as smooth as it can be, and no wobble.
Right.
Takes all the play out of it. And almost all the other systems I've seen, they may have an eyelet top and bottom. It's either carbon fiber or bicarta or some kind of belt crank, but you got to have something in the center or it'll wobble and eventually wear out.
There's nobody in this room that's strong enough to bend a 2-inch piece of music wire in half. And that's what you're basically trying to do.
It can't happen.
Can't do it. Not without tools.
No. And even if you're building a ringmaster, it's a smarter way to mount the belt.
Yep.
What else am I missing here?
Many ways to skin a cat. Tom and I agree on a lot of stuff.
Really?
Yeah. Come on.
I'm drawing a blank for the moment. Any questions anybody has about anything so far?
Any questions from out in the world? There's 13 guys watching.
Really?
Yeah.
We wanted to start with 18, didn't we?
No. If you have a question, type it in. Tom will answer it for you.
Yeah. I try to keep things as simple as possible.
14 now.
Part of keeping it simple is it's usually lighter, it's usually cheaper, it's usually more reliable. There's nothing that can come apart in these systems that they use. Oh, this is one thing I meant to mention earlier. People say, well, I use ball links because that way I can get the flaps and elevators exactly even. Okay. And they say, how can you adjust it when you do it this way? Well, you build it backwards. You make your push rods, elevator push rod, belt crank flap push rod. What I do when I build an airplane is I'll use a piece of masking tape, tape the horn to the back of the wing with a push rod in it, put the belt crank here, move it, and wherever it's neutral, I'll mark it, make a little notch in the wing, and that's where the pivot goes for the belt crank. It's neutral, all right? That's easy. How about the flaps, or the elevators in the back? The flap will go, how do you get them, make sure they're straight? You gotta say, well, I made 6 push rods and it never was completely, I always had up or down, they're always too short or too long. And so I went to ball links and, so I could adjust it after I put it together. No. You put your push rod in your elevator and you hook it into flaps, flap horn, and you tape the flaps absolutely solid, and you tape the elevators absolutely solid, or you can use sticks top and bottom with rubber bands so it won't flex. And then hook everything together, and wherever the stabilizer and elevator stop, that's neutral.
That's where you cut the notch for the stabilizer.
Yeah, exactly. Yeah. If you build it right, you don't have to adjust anything.
Right.
And if you're working from a fixed length, either make your push rod to the length of the plans, or and it's off at 1/16 of an inch or an 1/8 inch. It's not going to affect the way the airplane flies. And if you're disturbed by that, go make another one. They're cheap. But you don't need ball links. Now, these horns, you can bend a little bit if you want to level the wings. You need to tweak the flaps a little bit, or bend a little up elevator down, hold flaps, but bend the elevator a little. You can do that to a limited degree.
Frog Martin asks, what about Bob Palmer's differential flaps?
Oh, wonderful. They were backwards. He moved the inboard flap more than the outboard flap. Palmer was a model maker for Lockheed. That's what he did, a professional wind tunnel model builder. But he was not an aerodynamicist. And all those airplanes back in the day had a 2-inch longer inboard panel, and therefore a 2-inch longer flap inboard. And what Palmer was after was to get that inboard flap to go down further, to roll the airplane outwards, to roll it tighter on the legs. I mentioned Palmer was not an aerodynamicist. Anytime you make lift, you make drag. So what was wrong with that system was that he was rolling the airplane to outboard. If you ever flown one, you'll see this. And it'll wobble this way inboard. Anytime you deflect the flaps, it yaws left, it rolls right. Or if you're going the other way around, it yaws right and rolls the other way. I built a classic Palmer T-bird, a T-bird 2, a number of years ago. Flew it up here sometime 2005, 6, something like that. And I had differential flaps on it. The inboard panel 2 inches longer. But I hooked it up the other way around. I made the outboard flap move at full deflection 3/32 further than the inboard flap. So the drag on both wings was equal. Flew beautifully. And I used a standard horn on the inboard flap and an RCL horn adjusted to be the right length to match, so that outboard flap would move slightly more. Because remember, the inboard wing's 2 inches longer, the flap's 2 inches longer. By having it move slightly more, I'm creating the same drag on each side. This big flap, little flap, less movement, more movement. Flew beautifully. Now, I won vintage stunt championships in Tucson in 91 with a Palmer T-bird. But to make it fly properly, I had a clear plastic tab inset into the outboard flap to equalize the flap areas. Again, inboard panel 2 inches longer, flap 2 inches longer. But with that clear plastic tab on the outboard flap, the flap areas were now equal. So when you deflected it, you got the same drag on both sides. And no roll.
On 3/4 inch asymmetric wings, which is what I usually build, the outboard flap should be 1/4 inch, same root cord, 1/4 inch bigger on the tip cord.
It equalizes the drag.
To equalize the drag.
Yeah.
And a lot of people don't get that. Why is your flap bigger on the outboard side? Well, because then I don't have to run a stupid billy tab.
Yeah. Now, you said you talking about the differential flap. Palmer's airplane that's in the museum at Muncie. It was the airplane he flew in the 1960 World Championships. He flew the inaugural flight in the modern F2B World Championship series that they're still doing today without COVID and wars and stuff. But if you look at the airplane, you can see that the inboard flap has been trimmed about 3/8 of an inch along the tail because it rolled too much. And that's what he had to do to make it fly. So I guess that answers the issue about the differential flaps. It's a good idea, but they're only looking at one variable. They're looking at the lift variable and ignoring the drag variable. They just can't do that.
Rube Goldberg, you don't need that stuff.
Absolutely not. Let me talk about push rods. Again, I should have brought stuff with me, but I didn't. I don't want to limit my space. My push rods, I said they were 3/32 inch wire. But I sleeved the push rods with a piece of carbon fiber tubing. It's 100 thousandths ID, 5/32 of an inch OD. I get it from a place called Goodwin's that sells kite stuff. They got carbon rods, carbon tube, all this stuff. I get 10 of them. They're 4 feet long. I forget how much they cost. I actually cut them into 16-inch pieces. It's easier to ship it that way. And just slide it over the rod. Bend one end, slide it over the rod, bend the other end to the length that I want, and dribble at the NCA down inside, and it'll wick all the way through it. Let it sit there for a second, hit it with a kicker. No fair leads needed, no bushings needed. You can have this side of the fuselage completely open. You can't bend it. It takes all the loads in the world. It's very simple. And you don't have 6 pieces with all sorts of, carbon tube, wood plugs, wire sticking in it, wall links, all these things that can go wrong. It was John Simpson that clued me into that, and I've been doing that for 30 years, I guess, now, something like that.
I need to get the name of that place, because the hobby shop, I like that, doing it like that, but the wire doesn't quite fit perfect in the tube that I get.
Yeah, it's called Goodwin's, and they give you both the inside diameter and the outside diameter. I don't know the model number, I've got to shoot it on with it. But you gotta go Goodwin's, just GOODWINDS. I guess it's still around. I haven't bought any of that stuff.
That's what you're also using for bell crank to flap?
Yeah, on a model like this, I don't do it because it's short enough that it doesn't really matter. But on a big airplane, 60, 76, I sleeve the push rod from bell crank to flap because all the loads are going through that rod. You don't want them to flex. So, let's see. Am I missing anything else here? Anybody, any thoughts?
One to one. Explain one to one. Because I've tried to explain to them.
Well, one to one is commonplace. It's been commonplace since George Aldrich did actually not the Nobler that was published, because the Nobler that was published in model airplane reviews actually showed it 2/3 to 1 in the control hookup. I don't know what they actually flew, but the 1957 Nobler is the standard that most people are used to. It goes middle of the 3-inch bell crank, top of the top plate horn, and then 1 to 1. So you're moving the flaps and elevators the same amount. Some of that is variable around, if you got big flaps, small flaps, if you like one of Al Raby's airplanes that had 4-inch wide flaps and fairly small elevators, you might want more elevator movement and a little less flap movement. But for most airplanes that we fly, 1 to 1 works. I tend to build airplanes with full span flaps. The aerodynamic theory says the flaps are more efficient if they don't go all the way to the end of the wings, because you get the vortexes from lift generation coming off the ends of the wings, and if I make it wobble and bounce, the flaps go all the way to the end. In reality, it probably doesn't make any difference for what we're doing at 55 miles an hour. Probably doesn't really matter very much.
Kind of like those rat turds on top of the wing.
Yeah, the vortex generators that I see people put on models don't make sense to me. I was once upon a time a full-scale pilot and flew with people who flew, including Leroy Transit, they used to come up here, who had a Cessna 340, and he had vortex generators all over it. So he could go into a short field at slow speed. We'd come down final into a place in Florida, saw warning just howling, still airplane under complete control, because the vortex generators spin the air so it stays attached to the wing and the control surface. That's what they're for. Lose a little top end speed, but it keeps the air attached so that everything works. Lowers the stall speed. But the vortex generators on Roy Cessna were that far back from the leading edge of the wing on a Cessna, twin Cessna. That's be the equivalent on this airplane of putting them about right here, about a ½ inch back in the leading edge. And I see them all run down the high point of the wing, which on gliders, that's where they put spoilers to kill the lift so they can get them on the ground faster. Doesn't make sense to me. I don't see the theory with it, because it's not doing anything at that point. It would make more sense if you're going to do it to do it at the leading end and get the air working over the whole wing.
What I was trying to get at, and I'll explain it again. I explained it. No, I don't need that. I need the bell crank over here. Okay, this is 4 inches here, and this is 4 inches here.
Yeah.
So the way the control ratio works is you're trying to set it up for every bit that you turn this, the controls move the equal amount.
Yeah.
And that gives you better control than if you go like that and it goes full up.
Actually, the way I set it up, it ends up being about 40 degrees handle movement to 30 degrees of elevator movement.
Slow it down.
Slower. You can always speed it up by making the handle spacing further apart. That's easy to do. But if you get an airplane the controls are overly sensitive and you start coming down on the line, you lose leverage to pull the controls.
Right.
The closer you make, the harder it is to turn. So better to make the control system slow, and you got plenty of leverage to dump the controls in. I liken it to with this type handle setup, this type control setup. It's like fishing with light tackles. Everything's very light on the handle versus pull and jerk and everything else. You could feel everything you're doing. And also, let me talk about handles a slightly different way. This is a standard easy just hot rod.
Hey, for you guys out there, don't use those in static electricity air. You'll get shocked.
This is true. Had it done. But I see a lot of handles that are biased this way. And I also see people with handles that are biased this way say, fly my airplane for me. It turns inside real well, but not very well outside. Okay, well, let me put my handle on it, because that's what I'm familiar with. I fly the airplane's fine. So the airplane's fine. Let me see your handle. It's like this. Well, let me see if there's something here, like a stick or something. But
You need, what, a stick?
a stick or a piece of push rod or something that you can see on camera, but that's all right.
We got it. Hang on. Stick.
Stick, that way, oh, that's perfect. Perfect. That's a certified balsa stick there.
That's a stick.
If you watch anybody who's an expert flyer that's competitive day in, day out, they generally set, I've never seen anybody who didn't set the handle absolutely vertical. Now they may fly with their hand cannon this way or another, but the handle's set vertical with the elevator neutral. And then a lot of people like to bias them forward, like I was saying. That feels very comfortable. It's like a pistol grip. But the problem with that is it doesn't fit the way the human hand is configured when we fly an airplane. Now, if you got the bias like that, that's how much you can go down. That's how much you can go up. So you want neutral here, so you got that much down and that much up. So you can fly inside and outside maneuvers the same way. So if you start here, it's going to be sensitive going up and insensitive going down. And sometimes people will pancake airplanes inverted because they can't get enough down in it because the handle's so long. And it's also hard to fly inverted, in your level flaps like this because you tend to pull more up, which is what the airplane is going around.
17 watchers worldwide.
I'll be here.
Any questions out from the internet? Just Frog Martin, differential flaps. I guess you guys know it all.
Unless there's some specific, either off the internet or in here, I can't think of anything off the top of my head that would add to this. But I always go for simplicity, lightness, cheapness, if I can get away with it and it works. And the control ratios, the system from bell crank to handle, bell crank through the push rods to the flaps and the elevators. Experiment. One way to do this is get a profile where you can put different length flap horns on it. Because if you change the length of the flap horn and then one-to-one back, you're going to change the sensitivity of the whole airplane. Try different handles. Try wider spacing, narrower spacing. There's no one set handle, one set bell crank, one set system. Like one pair of pants is not right for everybody. One size shoes is not right for everybody. But if you don't look at what the parameters are and try all this stuff, you don't know what works for you. And once you know what works for you, I know what works for me. I can go out here and be competitive in this contest, and I haven't flown in 6 months. Because I've already trimmed the airplane and it's matched to me. And one or two flights get the needle and go out and fly. I don't have to relearn and adjust me to the airplane. I adjust the airplanes to me. And regardless of what somebody else might think is the right way to do things.
Now, I don't know that Tom's going to agree with me or not, but we'll see. My theory is you don't let people talk you into saying you have to have a 4-inch bell crank. You don't. A 3-inch bell crank will work just as well as a 4-inch bell crank.
Makes more sense.
No, you can set up.
Oh yeah, well, it depends on how far your output are.
Right, you just set it up because my Vipers were set up on 3-inch bell cranks because they were light.
It's just a ratio issue. As
Right.
long as you keep in the ratio, the bell crank can be this long as you keep in all the ratios the same.
The reason the 4-inch bell crank came about was because these guys started flying pipe motors and didn't realize that they added extra 2 ounces in the nose, so they wanted to leverage it around the corner. Well, if they just took the 2 ounces out of the nose, it went around the corner fine.
Yeah, these bell cranks, by the way, the Brodak bell cranks are actually the same as the old 3-inch top flight bell cranks you could get in the 70s and 60s. Just added more arm to it.
Right. It's the
But
same.
I like these because they're light and they're relatively cheap and they're available, and they work well when I put the bushy in them. So.
But the 4-inch makes it easy because you got a 4-inch bell crank, a 4-inch handle, 1-inch horns. So, 1.25 inch flap horn, 1 inch.
Yeah. mine are, instead of 1 1/4, they're 1 3/4, but
It's the same ratio.
Yeah.
You know, it could be 10 inches and 9 inches or whatever.
Yeah. Oh, one other thing, you know, on these horns, the other thing I do is I make folded tin bearings that I just take a piece of 3/32 wire, fold a piece of tin around it, squeeze it in a vise, and take it on, put it on there, and it anchors in the trailing ends of the wing. So, because when you're working it, that takes a lot of force right there. You'll start breaking hinges if that horn starts moving away from the wing, and of course you lose accuracy. So I always put my own bearings on the back to anchor them to the back of the wing. Not necessarily on something like this on the elevator, because it's a full span elevator, you've got hinges everywhere.
Okay, we got a question here. Come on. Let's see. Banshee 15 says, this guy's a wealth of knowledge. That's you. And our
That's about the only wealth I've got.
Are 1/8-inch horns needed? No.
My experience is not. I've got a new airplane that weighs 66 ounces on my scale, which I'm not accurate. 650 square inches, got a stalker 76 in it, got 3/32 inch horns in it. And I went to 3/32 horns because I was trying to do everything I could think of to cut weight out of the airplane. And I still came out 3 ounces heavier than what I was in.
You need to follow my paint seminar.
Well, you're not painting on foam wings like I am too. I'm starting out with a 2 or 3 ounce disadvantage right
It's
there.
at least an ounce.
Yeah. But, no, one of the things that always I thought was funny back, Al Raby, when he was active with mine back in the 70s, that's an amazing airplane, the C-Furies, Mustang, amazing airplanes, amazing craftsman, you know. What he did was extraordinary. Proved that you could make unusual airplanes fly well enough to win the nets. But Al was a fanatic about stiff flaps. Gotta have stiff flaps.
Hit 3 ounces apiece.
Yeah, and he would make his flaps out of like 3/8 balsa and put 4 layers of fiberglass cloth on them, and connect them with a 3/32 inch wire horn. But yeah, part of that was because the airplanes had dihedral, and you have 1/8-inch horns, they won't make the universal joint. You either have to use 2 horns because they won't flex and absorb the motion, you know, or you know, just you live with a 3/32 horn. But it doesn't make sense to have flaps that you could pry a house off its foundation with if it's all stuck together with a piece of wire.
Now this is for the internet crowd. I don't know how, depending on how crafty you are, we make our own horns.
Yeah.
We don't use music wire, we use drill rod.
Yeah.
So that you can tweak them.
Yeah.
The drill rod is tweakable, where that music wire is a bitch.
Yeah, my experience with these is they're tweakable to a limited degree. I used to get horns from a guy in Australia named Robin Hearn, who's Australian speed flyer and record holder in Britain and all that, but he made all sorts of hardware stuff. But about 7 or 8 years ago, he retired completely, and I lost my source of horns that were like that. Even the 1/8-inch ones you could tweak.
Right.
And they were good quality. They weren't pretty to look at, but they were good quality and they held up. I just don't have them available anymore. I use these because they're available. I'm trying to support Brodak and trying to support John when he was here. They work well enough for me. They're a whole lot better than the old top line horns and the Vico horns and all that stuff, sure. And you know, the price is fair given the givens. I'd rather depend on these than me trying to braze something together. I don't have that skill set.
Yeah, well, it's pretty simple. Follow our videos and you can see, I mean.
Is that a plug?
Yeah. Follow my videos Saturday at John's. We make them over John.
If there's not any other questions, we can wrap this thing up unless you got somebody on there that's got anything to ask.
If you got a question, we got 10 likes and 16 watchers. And if you got any questions, we'll wait a minute before we wrap this up. But if you got any questions, type them in now, and Tom will answer for you. So you can just shoot the shit until the question comes up.
Yeah, talk amongst yourselves.
Because it's time delay. I mean,
Understand. Can't think of a whole lot to add to this, but handle vertical ratios that you like, experiment, be curious, try different things.
keep it simple.
Keep it simple. Keep it simple, keep it cheap, keep it light, keep it durable.
You don't need variable adjustable horns and Rube Goldberg type extra camshafts in between. Have you seen that?
You don't even need adjustable lead outs anymore. You know, if you know where they go, there's no point in putting it in there.
Yeah, well, that's good. I mean, for some things, but if you don't know where they go, you better have
Well,
at least some adjustment.
if you started with from scratch and you've never built the airplane before, it makes plenty of sense. But if I've built 3 of these now, I know where the lead outs go, and there's no reason to put all that other stuff in there, the weight that goes with it. And that's one more thing that can come loose.
Right.
You know, one
Leave
more.
parts off.
Yeah.
Make the airplane light. Well, we have no questions so far, so if you want to wrap it up.
Thank y'all for paying attention. I hope this is helpful to you. Maybe we'll come up with something else we can do sometime.
Yeah, we can do another seminar. You guys leave a comment in the after the show's over. Leave a comment on the video, and if you in the next couple of days, if you'd like to see something else, we'll put it out there.
Yeah, push the like button, the subscribe button below.
Yeah, like, subscribe, share, and become a member. That member button is right next to the join button. It's the join button, and we'd sure appreciate that. But thanks for supporting Stunt Hanger. Fair winds, tight lines. We'll see you in the next video.
Thank you, Sparky.
See ya.
We're all.